Welcome to my project bazaar.com. Let we discuss about spatial entropy based global and local image contrast enhancement. A local intensity equalization strategy together with mechanisms to remedy artifacts produced by enhancement while ensuring the better image of our viewing. The reason for doing so is to understand what type of result we might expect to achieve with a given type of operation or what might be computational burden associated with a given operation. A method achieves contrast improvement in case of low contrast images, however it does not alter the image if the image's contrast is high enough. It does not alter the image if the image's contrast is high enough. Several tests on effect of contrast enhancement are performed. Experimental results shows the proposed algorithms to produce better or similar enhanced images than some state-of-the-art algorithms. This is mainly because SEC employs spatial setting data show the concept of the proposed algorithm alongside classical histogram equalization. This algorithm is named as Spatial Entropy-Based Contrast Enhancement in DCT. This method is able to execute both global and local contrast improvement without any visual artifact. This is a flowchart of our process spatial entropy based local and global image enhancement. In this flowchart procedure from our spatial entropy based enhancement process is to be followed. First of all, we have to take input image as low contrast images as Berkeley 500 images, and then apply SEC spatial entropy based contrast enhancement technique to be applied to the input image, the followed by function of distribute function and cumulative distribute function also, and then apply the 2 DCT in by replacing the 2 DCT we have to using the TWT in that operation for to implement the feature enhancement process of spatial entropy based local and global enhancement. By using the 2 TWT discrete wavelet transform from the output enhancement process is to be very effective. Then applying the coefficient weighting for coefficients of process of DWT. The DWT decomposes the 4 coefficients for input image. For coefficient for the output, the decomposed coefficients of DWT is to be weighted from the operation of DWT. The inverse process to be occurred for the weighted coefficients to be producted to the output of SEC. The SEC is produced from calculate the alpha and beta of our process. The alpha beta is to be applied to the output program from to inverse the process of the TWT. After inverting the process of DWT, we have the result of high contrast enhancement result. This result is highly effective by using the replacement of DCT to the DWT. The DWT is very effective because the high level enhancement technique is recently used in many usage. This is the MATLAB main window. That main window we have to set the path of our process. This is the workspace. In this process we have to use the variables should be stored in that workspace. This is the command window. The command window executed window for all processes of the MATLAB. In that folder is the current folder. The current folder should have the processed file for process the spatial entropy, local and global image enhancement. That entropy is calculated for image. The main new color.m file is for main file of our process. Right click that file, click run button. After click the run, we have to select the input image for our process. There is a local contrast images for 2 should be for input of Berkeley 500 images. That images we should have select the color image, 3-dimensional image, as well as we have to select the one file, click open. Those are output of our process. Now we have to see our output one by one. This is the input image of our process. This input is a purely color image as well as a three-dimensional image that the dimension should be noted in that line 200 into 200 the u into file. Generally defaultly we have to select the file. It should be the u into 8 data type file. This is the histogram file of input image. The spatial entropy based histogram is to be calculated for cumulative distributed function as well as the CCE function applied, and then we have to select the output image. This is the output contrast enhanced image of our process. This image should be developed by the applying SCC and DWT of our input image, and then as well as weighted the coefficients, and finally to inverse the process of DWT of our contrast enhancement process, as well as we have to the performance evaluation of purely enhanced image of our input. These values of or the input performance values of our process MAC, mean square error, SSIM and RMSE values of our process should be calculated. This contrast method, so using DWT is very efficient by using the replacement of a 2D DCT. The inverse process is also very difficult to handle, but because the 2D DCT have the two coefficient, and case of DWT should have the four coefficients. But using the DWT, the performance of our output is should be very efficient. Click OK. Now we have to conclude our project. The proposed computationally efficient global local contrast enhancement algorithm SUCA, which employs the spatial location distribution of degree levels of an input image to perform non-linear data mapping for generating naturally looking enhancement on different types of images. SCCE can be applied to both grayscale and color images, and it does not require parameter setting. It is statistically shown that require parameter setting can improve the contrast of an image, meanwhile produce almost no visual distortion on output images. SCCE preserves the shape of the input image grade level histogram while improving the contrast. This is mainly because SCCE employs the spatial location information of pixels and finds non-linear mapping, which is utmost important for several applications which require applied for such requirement. It is almost shown that the face recognition results on images enhanced by SCC is higher than those enhanced by other enhancement algorithms considered in this work. Thank you.